If a polynomial has degree n, then the graph of n has at most n minus 1 turning points. Okay? The graph of a polynomial has n minus 1 turning points, then the degree of f is at least n. Okay? So let's think about a parabola. It's defined by a function of the form ax squared plus bx plus c. A turning point is a point where my function goes from decreasing to increasing, or from increasing to decreasing. So a degree 2 polynomial has how many turning points? It has 1. It has at most 1 turning point, and that makes sense from what we know about degree 2 equations. So keep that in mind, that the number of turning points is always less than the degree of the equation by 1. Like I mentioned earlier, that if a factor of a polynomial occurs m times, it's said to have a multiplicity of m. Okay? If I have a factor with an odd multiplicity, so for example, a multiplicity of 1, that means that at this 0, so at x equals 1, my graph crosses the x-axis. If I have an even multiplicity at x equals -3, that means my graph touches the x-axis but does not cross it. So if I was to make like the world's roughest sketch of this right now, here's where x is 1, here's where x is -3. What I said was my graph, let's switch it to blue so we can see a little better. Because -3 has a multiplicity that's even, my graph touches the x-axis but doesn't cross it. But at x equals 1, my graph crosses the x-axis. Okay? So this can help us determine what our function looks like. Also, if we're given a graph of a function, we can determine the multiplicities. So let's take a look at that. Final note that if I have an even degree function and it has a positive leading coefficient, it opens up. If I have a negative leading coefficient, that's going to open down. If I have odd degree and a positive leading coefficient, it rises from left to right. Otherwise, if it has a negative leading coefficient, it's kind of flipped. It's flipped about. So it's going to fall from left to right. Here's a nice little table of the end behavior of polynomial functions. Remember, their domains and their ranges are all negative infinity to positive infinity unless it's a constant function. So let's practice finding a polynomial from a graph. So the first thing I see when I'm looking at this graph is my zeros. I'm looking for where my graph touches or crosses the x-axis. So I have 3 zeros here. I have that my zeros are -3, 2, and 5. I also see that I have 3 turning points. 1, 2, 3. Because I have 3 turning points, I know that my degree must be 4. So now I want to take a closer look at my zeros. So remember that where our zeros cross the x-axis, those are going to have degree 1. And where our zeros cross the x-axis, those are going to have degree 2. The last thing I need is a point on my graph. I could use any point, but I'm going to use when x is 0, y is -2. So if I have f of x equals a, x plus 3, x minus 2 squared, because it's got a multiplicity of 2 because it only touches my x-axis, times x minus 5, I need to solve for a. So I know that an x is 0, my f of x is -2. So I'm going to plug those in. I have -2 equals a times 0 plus 3 times 0 minus 2 squared times 0 minus 5. So I get -2 equals a times 3 times 4 times 5. So that's going to give me times -5. So that's going to give me 60. So I have -2 equals -60a. I divide both sides by -60. And I get that 1/30th equals a. So I can rewrite my function as f of x equals 1/30th x plus 3, x minus 2 squared, x minus 5. And if I wanted to get this in standard polynomial form, I could FOIL that all out. But for the sake of time and the fact that I know you know how to multiply, I'm going to leave that up to you. For this next example, let's look at our zeros. I have 4 zeros in this case. I have my zeros are when x is -6, -2, 0, and 3. I know that I have 1, 2, 3 turning points. So my degree must be 4, which is good because I've got 4 zeros. So I need to determine what my A is using the point, and I could use any point on this line, but I'm going to use the point when x is -3, y is 108. So if I have f of x equals A, x plus 6, x plus 2, x, we like lonely x's up in the front, x minus 3, I can go ahead and substitute in for my x and my f of x. So I have 108 equals A times -3 times -3 plus 6 times -3 plus 2 times -3 minus 3. So 108 equals A times -3 times +3 times 1 times -6, which is going to give me a positive 54. So I divide both sides by 54, and I get that 2 equals A. So I can rewrite my polynomial as 2 times x plus 6 times x plus 2 times x minus 3. And then I could FOIL this out to get it in standard form.